Today I'm going to talk about secure code, how to write secure code, what are the problems of writing secure code, why do we need to write secure code. Well, think of it as a big picture talk. So we are going to learn about a few techniques to defend against whole classes of vulnerabilities that we are dealing with all the time in source code auditing and also in exploitation. So first of all, why is becoming software security more important recently, and why do we lend more significance to it now? For a long time, security has been all about the network layer and filtering, firewalls, intrusion detection systems, port scanners, operating system fingerprinting, passive fingerprinting. So lots of techniques that are on the network layer. But actually, most of the critical attacks, even on the network layer, are on the application layer, are based on bugs in the implementations and in the source code that defines the functionality. So if you provide or use networked software, you can be darn sure that your net-enabled applications are likely to be vulnerable to various kinds of bugs, and mostly bug classes that are well known, but still happen to find their way into source code all the time. So as applications become more complex and we are moving up in the complexity we are dealing with when we write source code all the time, traditional perimeter defense, so saying this is internal network, this is a demilitarized zone, and this is the internet, it's becoming increasingly meaningless. So what I've been saying in my other talk, all the peer-to-peer protocols are re-implementing TCP, some of them just TCP over UDP, some of them just to bypass network filters, just to bypass firewalls. So it's pretty pointless, because if there is a need, if there's a business need in some sense, to ignore the firewall, that it's there, and just work your way around it, people will do it, and there seems to be something wrong with the concept of how we are dealing with the vulnerabilities. So, and big companies are starting to realize this. So there's this Jericho forum, which some of you might have heard about already. It's just a user group of really big companies, like a few hundred of a few world top players along, and they're saying the security industry right now is not providing us the tools we need to really fix the network problems we have, the application problems we have. And well, it's a bad thing, because we are spending money at this, and more money and more money, and unless they give us good tools, it's just like it's going to be a treatment of the symptoms all the time. So with this reasoning, they're saying if we are piercing through the firewalls all the time, then we need to shrink the perimeter. Maybe we don't need firewalls in the way we use them up to now for most applications, but maybe we need to shrink the firewall down to the individual host first. So host firewalls and host filters and host IDS and just the perimeter in total, and then shrink it even further to the individual applications, make the individual applications secure. And well, when we have the individual application secure, then some people are thinking about how we could we shrink it even further, maybe to data. But for now, what I'm advocating is mostly just making the applications more secure, because then firewall problems, we can still have firewalls and they might have some uses, but their limitations will be less of a problem. So basically, none of these low-level defense techniques that know very little about your applications will protect you against security vulnerabilities, for example, in your own web applications or in vendor-supplied web applications. And stack protection also only works against a very limited set of attacks, makes them harder, some of them so hard that probably they cannot be exploited. But those bug classes, even though they are still fairly prevalent on security conferences, I mean, we have lots of buffer overflow talks here, and lots of memory architecture, malloc talks, and working around various protection features from the hardware side. So it's fairly prevalent on this conference. And well, those classes of bugs are losing their importance already. Maybe because of these protection measures, but also because we have more and more complex software. So we are moving up the language hierarchy. We're using more high-level languages, which makes manual memory management and manual memory management problems like buffer overflows and double freeze and so on less likely to occur. Well, I'd like to clean up with some common secure software fallacies that I hear very often also on conferences like this one. So there are claims, for example, from the Aberdeen group that claims to be, I really don't know them, but in 2002 I read some article about them and then was looking for the paper. They made a comparison study in the security between Windows and Linux. And so they came out with some, in my opinion, unsubstantiated results saying that Windows is more mature because there have been more bugs and there has been more time to fix bugs all over again and again and then again. And well, people think this really works. I remember when I got started in security and just Linux admin stuff and so on some years ago, people were telling me that I should use SendMail and shouldn't experiment with those Qmail and Postfix stuff. So because, well, it's just snake oil. Those people are just claiming they made it more secure, but just look at SendMail. The bugs have been found. They are gone now. So we can just use SendMail because we found the bugs. Yeah. So they are really. You can look up the paper. If you look for Aberdeen and secure or security, something like that, you will find it. Well, another secure software fallacy is automated tools can solve your problems. Automated tools are really cool because if you think about it, security is a consulting business, but it's also a product business. So if you can make your choice, can you make a decision between making a security product and making a security consulting service, you always will want the product because with this you have linear growth. You can just create the product and then sell it to everyone and you don't need more people for it. You just need a few people to develop it. So from the perspective of the security industry, automated tools are really cool, but from the perspective of users, it's quite a lot of bullshit because if we could find those bugs automatically, Just think about problems like the halting problem, code analysis. We know we have proofs, we have formal proofs in computer science that we cannot really do formal proofs on any meaningful programs. So it's not going to really work. It can point out problems, but you will still need someone to look if those problems are real and like filter the false alerts from the real problems. Yeah.
Can you please name some of the main players of the Jericho Forum and tell me whether these are perhaps the same companies which in their the security bulletins might announce that,
just
does it work?
Maybe start over again.
Yeah. Can you please name some of the main players in the Jericho Forum and tell me whether these perhaps are the same companies which request you to use perimeter security in order to protect against some of the flaws in their own software?
I can mention a few of the companies participating in the Jericho Forum from the back of my head, but I don't know if they are main players or just running along.
Well-known companies.
Well, from what I read, but I might have a bad memory, so don't take it for given. But for example, I remember Swiss Charter Bank, Rolls-Royce, GlaxoSmithKline, and along these lines, like big companies that just have security needs. Not related to security, but their business is becoming more and more entangled with security problems.
Okay, thank you.
Well, did that answer your question? Cool. So, and another of the fallacies is good programmers write the same quality of code, no matter what tools they use. This is kind of the main point of my talk, and I'll just stretch it out a little bit and show it using the examples on the next few slides. Well, now to the boring part. To talk about software security, we really should first define what we think is secure or what a secure program is. This is pretty academic. We won't be able to verify it, but it still helps to keep it in the back of the mind. So my opinion is a program is functional. Like taking an incremental approach, a program is functional first if it does what the program developer wants it to do. And it is reliable if it isn't bothered by random events, so it just keeps on doing what it should do, even though random packets arrive and packets get corrupted and so on by chance. So it's quite, even if there are bugs, you won't see problems because the system just keeps running. But it is secure if it is reliable and just keeps on working, but it does exclusively what the programmer wants. So even if some specially crafted packet, which by accident, by random corruption or whatever, would never come to be, it still keeps doing only what it should do and not installs a rootkit or some kind of stuff like that. So I think that's a pretty thorough and wide definition of security. So if we can do that or anything approach that goal, even if we get nearer to that, our software will improve. So in an abstract sense, to write secure software, we need to know what the program should and shouldn't do. So we should define requirements and constraints. So often people forget about the constraint. So they're saying, well, this software, this is a real world example, by the way. The software should, and it's in the requirements, the software should allow the user to make a transaction from one bank account to another bank account. And well, what's not in the specifications, but what was kind of obvious to the programmer is to just make a drop-down field with all the accounts that the user owns that are related to the account. But they didn't explicitly check it. So it wasn't in the requirements. There were no constraints to make a transaction from some other guy's account to some other account. That's really what happens in banking software. So there is no process. There is no formal process. It would have been really cool if a friend of mine, Erwin Erkinger, he was supposed to give a talk on software reliability in the automotive and aerospace industry. You might have seen it in earlier versions of the program. If you had come here, because we wanted to kind of do like 2 talks behind each other and fill the gaps, because there are processes for secure software development, quite formal and strict ones, and but they have good ideas there that really would lend themselves to, some of them, to copying them and creating this kind of process, even for lightweight software development, like you need it in other areas. I think this can make quite a lot of sense even for hobby and open source projects to have very little but useful rules for how the software should be written. Well, then to write secure software, we need to write code in a way that avoids breaching those constraints, obviously. So to be able to know that we really are doing this, we need also to verify that the code that we've just achieved this goal. So I think one of the big reasons why it's not common yet that you teach programmers is because companies see it as a waste of time. I mean, if you fix bugs, hunt for bugs, and then fix the bugs, you have some kind of measure that you're making progress. So we as security consultants have the problem, if we want to sell actually useful tools and not just snake oil products, that we need to provide and think of a measure that we can give for how does the quality of well, I'm not talking about individual programmers, but the general output, the quality of the code output of the team needs to be measurable in some kind of way. Okay, now I'm going to make a slight digression. I'm going to use an example that I'm shamelessly stealing from Mikhail Zalewski, who really was brilliant in coming up with these techniques. And I'm not particularly making a point with the content here, but I'm more kind of using this to tell a story and introduce some concepts of complexity mathematics that Michael has been using. So, well, we have requirements for ISNs, which starts with ISNs should change all the time. ISNs, by the way, are in TCP, you use sequence numbers to look if two packets are, well, following each other, just to maintain state. Well, an ISN is the initial sequence number, so you don't want to guess that, because otherwise people who don't see the data can hijack the connection, which has been known. Yeah, okay, so I think in 1994, this ISN thing, it wasn't known when the protocol was designed, but in 1994 and before that in 1988, I think Robert Morris was involved with that. People started thinking about what are the possibilities if we are able to guess the ISNs. And they figured out it's possible to do IP spoofing. Later, Kevin Mitnick popularized this technique, and people writing books about this whole thing. So the story goes that he broke into the San Diego Center for Supercomputing by using an IP spoofing attack on our remote shell service. And well, since then, because this kind of bug or this kind of problem that IP spoofing is possible became really popular, vendors have added code to make their ISNs more secure, and especially since Nmap provided for some kind of measure if the ISNs are secure or not. So if you have measure, vendors are going to go ahead and try to get better in that measure. So it would be reasonable to assume that in 2001, where those bugs have been heavily exploited, where they still exist, or were thought to still exist, and not there where they were thought that they already had been fixed, you could reasonably assume kind of that those TCP IP stacks would be fairly secure already. But no one ever checked, no one verified it. So Mikhail came up with this idea of just basically let's make pretty pictures. Yeah, let's use things we know from fractals and so on for visualizing the strength of various sequence numbers. And this is called a phase space or state space. So you're mapping the closeness of, or the dependency of one value of a random function or any kind of function on previous ones. So you're trying to find out, are they related, just visually. So if we look at some demo, can we dim the lights slightly? Okay. Well, you should see there are more than the two strongly visible white rectangles there. You have points distributed over this space, over this phase space. And where many points hit near each other, on top of each other, it gets lighter and lighter and lighter. So the black places are the ones that haven't been hit yet. And we are looking at a random function for initial sequence numbers in TCP right now. So if we look at Linux 2.2, we have a fairly even distribution with it doesn't cover the whole area and so on, but it's fairly evenly spread out, which is good. We can't prove it's secure with that, but we can not prove that it's not secure. So we can keep on trying and changing the functions we use to visualize and so on. So if we look at Cisco IOS, we get pretty pictures. You have clear attractors, so it's definitely a lot easier. You need some more analysis to really be able to tell the numbers. Mikhail has been doing this. And you can just, if you search for Mikhail Zalewski, you will find those ISN, his research on ISN numbers. But you can tell just visually where problems might be. FreeBSD 4.2. HPUX, it's horrible. It looks really pretty, I agree, but it's a very, very short area that is covered. And then we have IRIX. I mean, yeah. Next, so Windows NT 4 Service Pack 3. I mean, it's pretty again. There's some stuff up. There's some stuff up there also which you don't see because of the projector, but it's spread out, but it's really easy. So Windows 95, it's horrible, it's very easy. And here's the funny thing about Microsoft. You need Microsoft jokes, you know? So in Windows 95, we have this distribution. So Microsoft is the only vendor who, in 3 years of work, actually managed to, well, fuck up their implementation more. And you can do the same thing with any kind of random numbers. You can do it with DNS resolver, like glibc. You can do it with various DNS servers. You can, with any kind of random numbers. It might even be, you might try it on a poker website to just find out, are there real random numbers behind that, or can I guess? So, and Dan Kaminsky has been using this technique after Mikhail first released this for a while too, so it's really cool visualization. So the basic thing, the common thing we have in all those pictures is we have certain attractors, however they look. They could look Mandelbrot, it's like fractals, it doesn't matter. Just think of it as attractors in a complex system, like any complex system, like the real world we live in, like a game of Go or chess. I mean, it's a bit different, but it's models, like behavior of molecules, stuff like that. You have certain patterns, certain things happen more than others. Yeah, Microsoft DNS server is pretty fucked up too. This is 2001, so there was another test later. I don't have those slides there right now. Some things improved, some didn't. So, well, and if you read a little bit more about those complex system stuff, you find out strange attractors are an inherent property of complex adaptive systems, which means self-organizing systems and self-creating networks and all that fancy stuff that has come up in recent decades. So the way I see it in software development is we're dealing with a complex problem, and we have a certain problem that we want to solve. We want to write a certain kind of web application. We have a general idea what we want, and we have a certain kind of set of tools that we are using. And if we combine those tools with our problem, then there are certain intuitive ways to solve it. So sometimes, for example, in C, it's very natural to just use character arrays for storing user input. So we just do that. There's an intuitive way we use this tool. You might use something entirely different in a different programming language. And if we map this together and just imagine this as a kind of terrain, certain things happen all over again. So we cannot easily visualize it, but this is what I think about it. Like, you have a second. I'm still a little bit tired from yesterday. So, Dark Lab party. So, good one. So, what I'm thinking here is basically, if you look at the web app, if you do pen testing, I think most of you have tried some kind of SQL injection attacks and stuff like that, just seeing if it's possible, just taking a field value, putting what's it called, a bracket? No. A quote mark there, just to see, is there an SQL injection there? And we do this all the time. I mean, companies are making money by doing this, which, yeah, so you just look, you put one quote mark there, and you get result, oh, Microsoft SQL server, blah, blah, blah. So, and then you start exploiting, start owning this host. So we have a fairly good idea, intuitive, of this terminal, where the problems are. We can try it out. So on the other hand, people who are aware of security have a good intuitive feel of where the security problems are in the code, and they try to avoid it, and they try to check, and they try to work around it. So I think it's possible for people to write better code, like just if you have good programmers, but I don't think it's the most perfect solution, because there are lots of programmers who are not good and don't have this intuitive feel whether this intuitive feel of where the problems lie. So what I'm seeing here is there you see those red things. I don't know what to call them, but they are walls. They are protecting us from certain holes. So if we had certain abstractions for memory management, for example, moving up to a high-level language, you very seldom, or you almost never see a buffer overflow in user code in a high-level language like Python. So what I'm saying is, if we want to help or to create more secure software, we need a certain way to verify that the software becomes more secure. And we need strategies to actually prevent bugs from being introduced to the code, not just hoping your educating programmers will help. Yeah. Okay, I basically already made most of those points. So you have null pointer dereferences, memory leaks, double freeze, format strings bugs, and so on. And those bugs very rarely creep into higher level software. So Perl recently has had a format string problem, but it's fixed. You fix it once. You fix the format string problem in the Perl interpreter, and afterwards, no Perl code should have this specific bug anymore. Another big attractor, problems you just see in many, many languages, is, for example, if two commands or two codelets with like just a sequence that has a meaning in a programming language is very close to something with a different meaning. So it's just one character exchanged or one character forgotten. Then it easily happens that a typo changes the meaning of the code. The same thing happens in natural languages. So yep. So I'm going to stress this further. I kind of have the feeling I have been convinced that there is more to writing secure code than just, well, not making bugs. So, but I'm going to present one more example to just show why people make bad software. And for that, I'm going to look at ESN1, which is a notation standard which is used in lots and lots of software and in lots and lots of security critical software. So just thinking about the applications where I've encountered ESN1, it's a simple network management protocol, voice over IP, H323, SSL, transport layer security, so HTTPS and so on. And TLAN manager, of course, the ESN1 compiler, SMIME, IKE, Kerberos, LDAP, and SMB. But you should also know that the telephone system S7 is using it. It's used in air-ground communication, in flight. It's used for tracking UPS packaging, or was it FedEx packages. The military is using a lot, so ESN is everywhere where critical software is. So, well, I just took it away, but just guess how many of those applications that we know, that we come into contact with without contacts to military or some specialized company software, just guess how many of these have had security problems. All of them. So I'm just listing I'm just giving a partial list of security problems.
Short question. Are you talking about bugs in ESN1? Muss man hier noch irgendwas anschalten? Ah, jetzt, danke. Are you talking about bugs in the ASN1 standard specification, or are you talking about bugs in the ASN1 tools that are common, the compilers and runtime libraries, whatever?
I'm talking about specific implementation bugs in separate re-implementations. So I'm not talking about a bug in one library and, oh, it's going to be a problem in all these programs that use it, like we had it with setlib. But no, it's independent re-implementations. Sometimes they copied from each other, but there are definitely a few independent implementations that had extremely similar bugs. So I have a second page here. So if you look at it, there's this Protos protocol test suite from the University of, I don't know, but just look for Protos. It's a protocol testing framework, and they... Oulu University in Finland. Thank you. So Protos uncovered bugs in lots of these applications, and for example, if you look at, do I have it here? The GNU-TLS issue. I mean, GNU-TLS basically is a project that was started as a re-implementation of OpenSSL. And, well, they made bugs in their ASN code, ASN parsing code again. So they re-implemented, but they still make bugs there. And I think there will be more bugs there. So because what I see from all this, even without being an expert on ASN1, it's just my intuitive feeling. If there have been so many independent bugs there, this must be a hard problem using C, because all of those bugs are in C implementations of ASN1. That's not, it's just empirical evidence that I'm presenting here. So I said it's a big picture talk, but I think that we will see less of those kind of bugs, so ASN1 might be easier to implement in a high-level language. Of course, it's not used that much in high-level languages yet, so we cannot know for sure. But I don't know of any ASN1 problems, similar ones to this, in any high-level implementations. And I know two, which is one in Java and one in Python. So it's a small sample size, so I might very well be wrong, so I'm open for discussion afterwards about this. Okay, so I think by just changing the way buffers are handled, you will not get so easily get memory corruption or memory problems. So contrary to everything I've ever been taught in almost every conversation, there have been some exceptions, but very few. Most people told me, well, I'm keeping using programming language X because all programming languages are equivalent in their power anyway. You can do anything in any language. You might still even occasionally hear that from assembler programmers. So it's well. And so syntax is relevant because we are dealing with a psychological problem. So the problem of developing software is a problem of bringing some idea that is in the head of people into software. So the bugs that happen are not, they are not bugs in the programming language, because you can write secure code and you can prove that theoretically you can write secure code even though you cannot verify that some code you have written is secure. But the place to fix it still, in my opinion, is in the programming environment. Not just in the programming language, but the whole framework, the whole way we translate our ideas into code. So this is semi-scientific mumbo-jumbo. I present to you the random rolling marble model. So the susceptibility of a language for a class of bugs is the probability of a randomly chosen programmer to make a mistake from that class. So if you give the same problem to lots of programmers, you get statistics how likely you can exploit the same, you can exploit the same SQL injection attack in 5 different independent implementations. So what do I think are good programming environments that help with keeping the code secure? First of all, I think magic is often really bad. None of those rules are absolute because they're good counterexamples. So what do I mean with magic? I will show you on the next slide. Then this programming language should be sufficiently expressive. So if the programmer has to write something entirely different than the idea he has in his head, he has a problem because he needs more brain power to just understand what is happening. Then you want to avoid unnecessary redundancy because it leaves more room for making bugs. Less code is more than better code. You want sufficient Hamming distance between code words with different meaning, which means two things that mean different things should look different. So you can just skim over the code and understand or get an idea of what it is doing, and it also avoids typos. Then there's the principle of least surprise. So pretty obvious. You don't want to be surprised when you write security critical software or a banking transaction. Oh, that's nice. I can make a transaction from this account to my account. It's nice. So you don't want to be surprised there. So the best way to do things should be simplest. Easy things should be easy, hard things should be possible. I shamelessly copied some of the points here from the Zen of Python because Python is really nice, secure programming language. There are other good ones too. So, well, and now I'm bringing negative examples because this is what it's really about. There seems to be a big trend in higher level programming languages towards 2 or maybe 3 camps. You have the camp that is Java and .NET, and you have the other camp that is Perl, PHP, Python, and so on. So dynamic languages, static languages, and a few languages that go in between or other concepts. But these are the main camps right now in sheer numbers of users. And PHP is a big part of that. So I'm seriously using it to show bad examples of bad code. For example, in PHP, user input automatically is put in global variables. So if you pass just anything you want to any PHP script, it's put into a variable. And well, if you don't pass it, this variable is just undefined. You don't get a warning or anything. I mean, there's no data in there. So you have an unlimited amount of empty variables, and you never know that you just made a typo or forgot to pass it, and so on. So this can get a really bad problem, this second point. Especially if you look at the third point, how types are handled in PHP. For example, when two variables of different type get compared, one of them gets implicitly converted, which means ID equals myString is true if either 1, ID is a string that contains myString, or more intuitively, if ID is an integer with value 0, then myString gets converted to an int of value 0, and it's true too. So and one of the worst points is I sometimes have to work with PHP. So use whatever language makes sense, and if you have code you have to fix because that's your job, then work with PHP. So the problem is the only way I found, I asked on our IRC channel back then, to download websites from a remote location is by having enabled fopen, include, and a few other functions to not only be able to open files, but also be able to open remote URLs. So that's really convenient if you want to say, well, give me that URL and so on. But in my opinion, it would. Let me point out the problem with that first. For example, with include, and you make a template system and say, I want to include the about page into my general template, so I do include about.inc, something like that, and you pass the about.inc in a variable, like many websites do that. They are dynamically changed, just pass to the main program the name of the include file for this specific page. And the user inputs an URL, then a remote file is included, and then locally executed. So this is a direct remote shell access. The problem with it is, I mean, you can turn it off, but if you turn it off, then you have to open a socket to a web server if you want to download something, send get/http 1.1 host colon and so on. So you have to build your own HTTP implementation if you turn off this feature. So this magic is really bad because it forces me to deal with a big attractor for security problems with no choice to just take the functionality and say, oh, I don't want to F open, I want the URL open. So you could just change, you don't want magic, you don't want one function to do two different things dependent on some random variables and config file options. It's really weird. Then there's a problem that's common with many languages. The problem is there's not sufficient expressiveness. So high-level languages can help here because you want to express what you're thinking. If you want to iterate over like you want to make a pay raise for all your employees, you want to iterate over all the employees and give them a raise. So pretty obvious. You can write it down for element in arguments, do something to the element, easy. Up there, by the way, is a bug before someone points it out. So for x, like what are we doing up there? We want to iterate over a list. We are not actually using the variable x. I mean, I'm literally not using it here. Actually, instead of argv square brackets 1, there should be argv square bracket x. I made that bug in my first slides by accident. I left it there because it just shows you make those kind of bugs. There's room for bugs even if you don't want to do something simple. So down there, that's much nicer, and it works because of a high-level concept which is called iterators. Then regarding sufficient expressiveness, another negative example. If you want in PHP to read all the file names from a certain directory, you would do it like this. You would first store within the while loop to store it in $file, and then you have to compare using a type-aware. So PHP has this problem with automatic type conversion. So they introduced, to fix it, they introduced the equal and not equal operator. So we have another character there just not to do type conversion automatically, which every same programming language does anyway. So it just adds up, it's craft. Instead, we could just say, well, for all the files in that directory, give me the file name. So then there's the problem of code duplication, which makes it hard to read and maintain. So for example, Java has a problem there. It's getting better with things like generic containers and genericity, and also with aspect-oriented programming and ideas like that. But still, the statically typed languages do have a problem with code requiring to be duplicated. So maybe someday someone will solve that. Right now, it's a big problem. Then there's double use. This is a controversial point, but there's double use of the brackets and the indentation. So if you ever taught a total beginner how to program, you will notice they all the time have problems with right indentation. So either they make the wrong brackets, the wrong amount of brackets, or it doesn't match with the indentation, or the other way around. So they always confuse this. So one of the reasons why I really enjoy teaching Python to total beginners is that they don't get confused by simple indentation. They just see the blocks, they see what they want to do. So while it's unusual, and it might not be necessary to write secure code in Python, you might not need this feature, it actually makes a lot of sense. Even though from an adoption viewpoint, it might have been a bad idea because many people get scared because it's new syntax. Then the sufficient Hamming distance. This kind of bug is common. Something like this has been tried to be introduced into the Linux kernel too, I think. I don't remember the exact bug, but you just lose one equal sign and suddenly you have an entirely different meaning to the code. Then there's another problem where you just lose one comma in C, and suddenly you have automatic string concatenation because string concatenation is implicit. So you would want an explicit string concatenation operator like the dot in Perl there. So there's something good to say about Perl there. I don't know if it also has automatic string concatenation. Then there are some defense techniques. So much of the work I've been recently doing on all this, how to write secure code stuff, is just looking at what am I doing as a penetration tester? Where am I looking for bugs? And then thinking about techniques of reformulating the problem so those kind of bugs are harder to make for programmers. So one of those defense techniques is path normalization, where instead of just concatenating any random way, you first well, in this case, you don't do input validation. You just take whatever you get, you do whatever you want with it, but afterwards, in the end, you normalize it. You put it into a format that allows input validation after the fact. This just works for strings. I have a more, but slightly more complicated type-paste solution, which would also work here, but why bother? This works. So normalizing means you remove all the dot, slash, and I mean normalized and absolute. So you replace all the local paths with global paths. And in the end, then you only check, does it start with the jail directory? Does this path lead outside of the directory where I actually wanted to read the file from? So any kind of dot, slash to read etc passvd is not going to work anymore with this. Good, then there's another example. I haven't finished my slides for this, but basically the idea is if you get user input from any user source from a keyboard and transmit it over a wire, it's text. It's also a string, but it's text. And text has and if you have some template, HTML template, then you have a string also, but it's an HTML string. So there's a different type. You have HTML in there. It's readable as HTML, not as text. If you try to read it as text, you have lots of weird characters that don't make sense in text. So, and the other way around, you might have weird characters in text, and they make very weird and bad for security interpretations in HTML. So by making it explicit that there are different types of strings allows for enforcing conversion, because the problem we have there is this is not about introducing something that is really annoying because you have to do it all the time. This is about, right now we are teaching in those of us who are teaching courses in writing secure code or how to fix web applications and so on. We are teaching day by day, well, if you use user input for an SQL query, just escape it. If you use user input in an HTML page, escape it every single time. So you need to escape every single time. So how do I get my framework, my programming language, my programming environment to force me to escape every single time? In this case, I can use the type system. Also in You can do the same thing in Python. You can emulate it in various ways. You just enforce that strings get converted to however they are used. So I think this is the end already. Yep, it is the end. So I'm just going to summarize. You need to know what you want to do and what you don't want to do if you want to write secure code. Good tools seriously improve code quality, even with bad programmers. Good programmers are definitely a lot better than bad programmers, obvious. Coding standards set a baseline for code quality. So the future work that I'm planning on this is if you have code standards, maybe you can bring part of them into some kind of abstract format and actually use this to verify that certain things that make sense are actually done. So I'm not talking about full static analysis to find bugs, but I'm talking about changing the way things are implemented for doing, like, changing the way you program so it's easier to analyze, easier to verify, and easier to not make a bug. And yeah, this is the next big thing. How can we put this whole thing, this whole software development process into a real framework, into a methodology, and add the necessary verification steps that they become effective and not just any not just anyone can go to companies and claim he helps them make more secure code, because then they are not going to make more secure code. But the same thing applies. If you make this methodology, I'm sure some of the open source projects can also benefit from this. Some of them are using extreme programming techniques and so on. So there's a lot of room there, and I would like to discuss afterwards on how we can proceed from there. So that's been the talk. Other questions?
Which coding standards do you recommend? Which coding standards do you recommend?
Well, very much agreeing on certain ways. For example, we are dealing with a complex environment there, so we need to we cannot just say very high level we do it like this, because this is not going to work. When we do penetration tests, we know where to expect bugs, so we have to fix it there where people have just psychologically make those kind of bugs. So, for example, using a simple coding standard would be to say we use prepare statements for all our SQL queries, because then if we do that and we only use constant strings for the template, then there won't be an SQL injection problem, because prepare statement fixes the problem. We could also use something like this type system approach. Just make this a coding standard and then look for uses of, well, verify when you do a check into the source code repository, is some other way to make a database access done, for example. Or check for, well, basically doing tainting checks to some regard, but also doing basically verifying that these things you agree on. Basically, I don't have any fixed set of methodology right now. I've been working with a few companies recently. After doing a penetration test, I made a workshop with the team, and we've been looking at the kind of problems they had in their source code and then discussing these exact things. Oh, this is a problem, you made a typo there. Or, oh, this is a different type, so maybe we should abstract this further. Or there's much too much code. This decision function is 8,000 lines long, so that's not a good thing. We need to make it shorter. And there's a pattern that helps with that. So if we use a dispatcher and not if, it gets better. So I would like to have to develop a standard set of how to develop secure code, independent of the programming language, focused on the problems we are having, but this is going to take some more time.
You mentioned ASN1, and I remember well when this was on the security bulletins. How come that this applied on several platforms and so many services at the same time when this is, as you said, an implementation problem? I thought that implementation would be pretty different on different OS platforms.
Me too. So, well, obviously, they copied from each other, definitely. But also, there are re-implementations. So,
But regarding their license policies, they shouldn't be able to copy.
I'm not a lawyer, so I wouldn't know. It's just there. It's just evidence. I'm trying to interpret it.
Okay, thank you.
Thank you.
I like your idea of the type system for tracking data validation. Are you aware of any implementations in real-life applications of that kind of stuff?
I know of maybe 4 implementations. So there are 2 Java implementations, which we worked on at, well, 2 of my customers. And I know of 1 implementation that I made in Python and 1 implementation that Andreas Bog made in Dylan. So both of these are just experiments to get a feel for what's possible there.
Okay, thanks.
Thank you.